Hi friends, welcome to the next part of another electronics. I hope you all have been solved the questions whatever that we have shared in the last session, right? So we are solving problems based on bipolar junction transistor. I hope you all have been able to solve the problems because in the last lectures till last lecture we have been solved so many questions. So let us continue from there. In the last section, I had given one homework question. I don't know how many of you solved this question. If you have solved this question, just do let me know your answer in the comment section. Okay. See what is the given question. Assuming that collector to emitter saturation voltage is 0.7 and the value of beta equal to 50. Okay. The minimum base current required to drive the transistor in figure to the saturation is dash. So that is the given diagram, the minimum base current that they are expecting to drive the transistor to the saturation region. How many of you did this question? If you solved this question, just do let me know the answer in the comment section. I don't know actually how many of you did this. You can take 1 or 2 minutes and you can try to bring the answer. No one? Yes, very good. 56 microampere. Okay. Geeta, Chitra, 0.056 milliampere. Nice, nice. So anyway, you people did it right. Very good. So what is the given? They clearly told that they are going to drive the transistor in saturation region. Okay, sir. So if we have to drive the transistor in saturation region, how to solve this question? We all know how to bring the relation between all other parameters, right? So just it is about the transistor. நம்ம என்ன பண்ண போறோம் அப்படின்னா transistor வந்து suppose let us take collector to emitter voltage is 0.2, beta value is given. They are asking minimum value of beta current. You have to observe. இங்க வந்து என்ன ஆகும் அப்படின்னா there will be a doubt arises. The first thing is I had given some calculation. Whenever you are solving any problem by assuming that your transistor in saturation region, I told you to not do something. What I told you, the relation collector current IC equal to beta times of IB. This is called linear relation. So this linear relation is not valid in saturation region. You cannot directly take this equation I said. I hope you all remember these things. And the second thing is here, sir, அப்ப இந்த ரிலேஷனை வந்து நான் இங்க அப்ளை பண்ணலாமா கூடாதா? That is the next question. இங்க கொஸ்டின்ல என்ன சொல்லியிருக்காங்க அப்படின்னா just consider the given data. Transistor வந்து என்ன ஆக போகுது அப்படின்னா it is about to enter into the saturation region. அப்பதான் enter ஆக போகுது. It means what? So if we are pushing the transistor to saturation region, prior to that what? It is trying to go from active region to saturation region. Transistor on la irukka linear region la. So it is trying to enter into the saturation region. We are pushing it back to the saturation region. It is about to enter abdina, you can take this like. So what we can take is collector current IC equal to beta times of IB. We are going to use this relation because just we are entering. This is the point. We are entering into the saturation region or we are pushing the transistor into saturation region. So அப்ப எங்க இருக்கும் நம்ம just we are in the deadline of one region to another region. So இங்க இருந்து நம்ம இந்த ரீஜனுக்கு புஷ் பண்ண போறோம். Pushing in the sense அப்ப நம்ம எங்க இருந்து புஷ் பண்றோம்? We are going to travel from linear zone. I am assuming that the transistor is shifting from active region to saturation region. Okay, sir. Then how can I proceed further? Then remaining everything will be fine. So just it is reached the saturation region from here to here. அப்போ நம்ம என்ன பண்ணிக்கலாம்? As usual, they have given collector to emitter voltage. When we are just entering saturation region குள்ள enter ஆகும்போது expected voltage என்ன? 0.2 voltage. Just we are entering into saturation region. Beta value is given. Now if you apply KVL, you know how to highlight this battery polarity. So this will be minus plus 3 voltage. For the resistor, current entering point plus leaving point is minus, and the voltage drop of the resistor can be written as collector current IC into 1 kilo ohm resistor. This is the voltage drop. Now if you apply KVL from top to bottom, write the KVL equation from collector to emitter. You know how to write? Minus 3 voltage plus collector current IC into 1 kilo ohm resistor, 1 into 10 power 3, plus collector to emitter voltage is 0.2 voltage equal to 0. Minus 3 plus 0.2 will give you minus 2.8. So from this I can say collector current IC into 10 power plus 3 equal to 2.8 plus 2.8. I am passing it to the right side. The border, so I am just applying the relation. What is the relation that we are going to keep it here now? So collector current IC equal to 2.8 milliampere. From this I can say we all know IC equal to beta times of IB. So the value of IB will become collector current IC by beta. So this is 2.8 milliampere in the sense 10 power minus 3 upon what is the value of beta? 50. Yes, beta is given as 50. So by substituting this value, what you can write? The answer. So if you reduce this, wait, let me try to, it will become 0.28 by 5. So it will be 0.5 times of 5 will be 25, remaining is 3, 5, 6 times will be 30. So 0.56. If I will cancel it, again it is not getting cancelled, right? Hmm. 0.056, sorry guys, milliampere, or I can say it will be going to be 56 microampere. I hope many of you did the correct answer. I'm really very happy to seeing your answers in the comment section. So let us continue with the same flow. Let me bring the next question. It's a little bit new one, but not new one. Let us see. I'm including one more device with our BJT. And let's see how many of you are trying to give the answer for this question. One minute, I'm just taking the question. Yes. The given question is having a transistor it is given like this, NPN transistor. Next what they did is they have taken one diode here, that too will be represented like this. Do you have any idea about this? I also don't know. Let's see how to solve this. Okay, they have given like this here. They put some resistor here. Okay, this is the given circuit. Then they are telling that from this point to this point, they are connecting a voltage source, DC input voltage, and its range is given as 20 to 30 voltage. So they are going from 20 to 30 voltage. Next, they have given some other data. This resistor is 20 ohm, they told, and this resistor is not given. They are simply calling it as base resistor. They are calling it as BZ, and they are calling it as IZ. it has been connected like this, and they are calling it as ICE. Here what happened is output they are collecting between these two terminals, they are calling it as V0, and they are calling it as this, call it as VB. Okay sir, fine. Now what we need to do, let me read the question. Actually what they told is the transistor shunt regulator. Let me write it here. The transistor shunt regulator, that is the name of the above circuit. The transistor shunt regulator circuit shown in the figure. Okay sir, first data. Next figure as regulated output voltage of 10 voltage. Regulated output voltage V0 equal to 10 voltage when the input varies from 20 to 30. When input voltage Vn varies from 20 to 30 voltage, that is the given data. The relevant parameter for the Zener diode, the relevant parameter for the Zener diode, the relevant parameter for the Zener diode, they told, let me write it here, Zener diode under the transistor R, under the transistor R, they told that the value of Vz equal to 9.5 voltage, okay sir, comma, the value of base to emitter voltage 0.5 voltage, comma, beta 2 equal to 99. Neglect the current through RB. Neglect the current through 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 RB. Neglect the current through RB. Then the maximum power dissipated in the Zener diode under transistor R. The maximum power dissipated, the maximum power dissipated in the maximum power dissipated in the Zener diode under transistor. Is that D means Zener diode, transistor R dash. That is the question. You can just read the question. Don't think that the question is very big. எங்க ஸ்லைடு ரொம்ப குட்டியா இருக்கு, அதனால நான் எழுதுனது உங்களுக்கு பெருசா தெரியுது. இது ஒரு 3 lines தான் வரும். Take your time. If you have any idea, just you can drop your answer. இந்த கொஸ்டினை சால்வ் பண்ணுறதுக்கு உங்களுக்கு நிறைய பேசிக்ஸ் தேவைப்படுது. நீங்கள் Zener diode ஃபண்டமெண்டல் பேசிக்ஸை படிச்சிருக்கணும், அதோட ஆப்ரேட்டிங் கேரக்டரிஸ்டிக்ஸை படிச்சிருக்கணும். அப்படின்னா என்ன, அதுக்குள்ளே என்ன நிறைய இருக்குது அதுக்குள்ளே படிக்கிறதுக்கா? அப்படியெல்லாம் எதுவும் கிடையாது. ஃபண்டமெண்டலி if you know the some chota basics, Zener diode பற்றி லைட்டாக தெரிஞ்சிருந்தா போதும், this question will become very easy. காலேஜில் படிச்சிருப்பீங்களே, நம்ம எதுக்காக Zener diode வந்து யூஸ் பண்ணுறோம் அப்படிங்கிறது only one word தெரிஞ்சதுன்னா this question you can easily solve this question. Let's see. You will be having your 2 minutes. You can drop your answer. if it is possible. Just try. Any idea? Okay, fine. Yes, you people are still having some idea, but trying it. I'm try பண்ணலாமா? I just wanted to share some basics of Zener diode here. In the Zener diode, this Zener diode basically having some special characteristics. You know, if we take the normal diode with the Zener diode, we will go to the next slide. If we take the normal diode, 1 minute. So you know the representation of normal diode. This is normal diode. And its correspondent characteristics if we draw with the x and y axis, you know how to draw it, right? Let me show you. If I am taking this is x and y, if we draw the normal diode characteristics in forward bias, it will be like this. Of course, this is called cut-in voltage. If I am taking silicon diode, it will be 0.7. For germanium, it will be 0.3. You all know that. Sorry. So this is forward bias, and y-axis is indicating the current flow through the diode. X-axis indicating the voltage drop across the diode. Similarly, in the opposite, this is negative voltage or reverse bias. This is negative current flowing through the diode. So when the moment we are injecting positive voltage through the diode, this will be the characteristics that you can observe. What will happen is maximum voltage drop across the diode will become 0.7 in forward bias. That's all. Then it will turn on. It started carrying huge amount of current. Up to its maximum specific rate, it will carry the current. When I am trying to reverse the polarity, suppose if you are injecting negative voltage through the Zener diode, through the normal diode. Negative voltage means what? Positive voltage means from anode to cathode we are injecting positive voltage. So in that case, this diode will be replaced by its equivalent circuit. Positive plate, negative plate, plus or minus 0.7 voltage. That is practical case. Suppose if they are telling that the diodes are ideal, then you have to short circuit. Ideal diode means what? Forward voltage will be 0. When the moment you are trying to inject the positive voltage, immediately when you are injecting 0.001 voltage itself, diode will turn on. So approximately diode will be acting as a short circuit and it will start at carrying the current. That is in case of ideal diode. Okay sir, fine. Ideal diode means forward voltage drop is 0. And now I am reversing the polarity. I am taking the same diode, but I would like to reverse the polarity. I am injecting negative voltage. Negative voltage means diode will be behaving as a open circuited. But you know, a very minor amount of leakage current will be there. Very less amount of leakage current will be there. So that leakage current is called reverse saturation current. So you can observe, if you closely observe, a very minor amount of like this. That's all. Current will not go beyond this value. So this region is called reverse operating region, ROR, reverse operating region. This is called a forward operating region, that is forward bias region. Now, so what will happen is your diode will tries to carry some very minor less amount of leakage current, that too in nanoampere. Under that situation, if you observe the voltage, its correspondent voltage is called maximum breakdown voltage. Maximum breakdown voltage, VB. This is B denotes, BD denotes breakdown. What is the meaning of breakdown? இப்போ நம்ம பஸ் எல்லாம் போயிட்டு இருக்கும்போது பஸ் பிரேக் டவுன் ஆயிடுச்சுப்பான்னு சொல்லுவாங்கல்ல, என்ன ஆகும்? உள்ள ஏதாச்சும் கியர் ஏதாவது புகுஞ்சிருக்கும், இல்லை டயர் ஏதாச்சும் இப்போ ஃபங்க்ஷன் ஆகிட்டு இருக்கும், பஸ் ஆஃப் ஆகிட்டு நின்றுட்டு இருக்கும், ஸ்டார்ட் பண்ண முடியாது. ஸோ அப்படின்னா என்ன அர்த்தம்? பிரேக் டவுன் மீன்ஸ் பேசிக்கலி கால்ட், இட் இஸ் இண்டிகேட்டிங் தி பார்டர் ஆஃப் டேமேஜ் பாயிண்ட். இதுக்கு மேலே நம்ம ஏதாச்சும் பண்ணோம் அப்படின்னா அது ஆட்டோமேட்டிக்காக டேமேஜ் ஆகிடும். ஸோ தெர் இஸ் அ பவுண்டரி ஃபார் எவ்ரி திங், ஈவன் இன் அவர் லைஃப் ஆல்சோ. நம்ம எந்த ஒரு விஷயத்தை பண்ணாலும் சேச்சுரேஷன் பாயிண்ட் இருக்குன்னு சொல்லுவாங்க. யூ ஷுட் நாட் டிராவல் பியாண்ட் தட், ரைட்? ஃபைன் சார். எஸ்பெஷலி இப்போ இந்த ட்ரிங்கிங் பீப்புளுக்கெல்லாம் சொல்லுவாங்கல்ல, ஹூவர் அடிக்டட் டு ஆல்கஹால், ஒரு பர்டிகுலர் லிமிட் வரைக்கும் ட்ரிங்க் பண்ணாங்க அப்படின்னா தெர் வில் பி நோ இஷ்யூஸ், எதுவும் ஆகாது, மைண்ட் வில் பி அண்டர் கண்ட்ரோல். இது தாண்டிச்சு அப்படின்னாக்கா எவ்ரி ஒன் வில் பி ஃபினிஷ்ட். அவங்களும் தே ஆர் வெரி ஹாப்பி, ஆனால் அவங்கள சுற்றி இருக்க எல்லாரையும் காலி பண்ணுறாங்க. That is called unsaturation zone. It will be automatically damage everyone. So like that, but here என்ன நடக்கும் அப்படின்னா diode damage. Of course, over drinking is injurious to health. It's also not good for human health also, right? So என்ன ஆகும் அப்படின்னா ஒரு particular limit வரைக்கும் if you are drinking, then there will be no issues. If you go beyond that, automatically it will spoil your life. Spoiling in the sense, நம்மளோட health, physical body will get affected. So like that, this physical nature of the diode also will get damaged. It will be breakdown if you cross this breakdown voltage. So normal diode will be operated only in two regions. One is called forward bias region, another one is reverse bias region. People also called forward bias region. This is called reverse bias region. Operating region or bias region, something, sir. சார் சப்போஸ் இப்போ நான் வந்து ரிவர்ஸ் பயஸில் ஆப்ரேட் பண்ணணும், இந்த பிரேக் டவுன் ரீஜியனை தாண்டினதுக்கு அப்புறம் எனக்கு வந்து கேரக்டரிஸ்டிக்ஸ் இப்போ ஃபார்வர்ட் பயஸில் எப்படி வருதோ அதே மாதிரி ஃபார்வர்ட் பயஸில் ஓகே சார் 0.7 வோல்டேஜ். ரிவர்ஸ் பயஸில் இந்த பிரேக் டவுன் வோல்டேஜ் அப்படிங்கிறது எப்படின்னு பார்த்தீங்கன்னா ஒரு மேக்ஸிமம் எபிலிட்டி. மேக்ஸிமம் எபிலிட்டி அப்படின்னா டயோட் வந்து ரிவர்ஸ் பயஸில் இட் வில் ட்ரைஸ் டு யூ கேன் கீப் ஆன் இன்ஜெக்ட் சம் 10 வோல்டேஜ் 20 வோல்டேஜ். திஸ் வேல்யூ வில் பி இன் வோல்ட். இட்ஸ் நாட் 0.7 0.8, இட் வில் பி 10 வோல்டேஜ் 5 வோல்டேஜ் 3 20. அந்த மாதிரி பிரேக் டவுன் வோல்டேஜோட லெவல் வந்து கொஞ்சம் அதிகமாக இருக்கும். பிகாஸ் அது நீங்கள் வித்ஸ்டாண்டிங் எபிலிட்டி ஆஃப் எ பர்சன் ஃபிசிக்கலை வந்து நீங்கள் டெஸ்ட் பண்ணுறீங்க, அவனுக்கு எவ்வளோ பொட்டன்ஷியல் இருக்குது அப்படின்ட்டு. ஸோ டயோட் வந்து மேக்ஸிமம் அதால் முடிஞ்ச அளவுக்கு ட்ரை பண்ணிகிட்டே இருக்கும். ஸோ மேக்ஸிமம் வோல்டேஜ் பிரேக் டவுன் வோல்டேஜ் இட் இஸ் இன் ரேஞ்ச் ஆஃப் சம் 5 to 10 20 அந்த மாதிரி இருக்கும் வோல்டேஜ். இஃப் யூ ட்ரை டு அப்ளை பியாண்ட் தட் வோல்டேஜ், டயோட் வில் கெட் டேமேஜ். ஸோ வி அண்டர்ஸ்டுட். பட் சப்போஸ் இஃப் யூ வாண்ட் டு ஆப்ரேட், இல்லை சார் இந்த ரீஜனை தாண்டதுக்கு அப்புறம் இஃப் ஐ எம் அப்ளைங் 20 வோல்டேஜ் நான் அப்ளை பண்ணுறேன் அப்படின்னா அந்த 20 வோல்டேஜை நான் அப்ளை பண்ணதுக்கு அப்புறம் என்ன ஆகும் அப்படின்னா டயோட் வந்து ரிவர்ஸ் பயஸில் கண்டக்ட் ஆகணும் சார். கேரக்டரிஸ்டிக்ஸ் எனக்கு இப்படி வரணும், ஃபார்வர்ட் பயஸ் மாதிரியே ரிவர்ஸ் பயஸில் வரணும், பட் வோல்டேஜ் ரேட்டிங் கண்டிப்பாக ரிவர்ஸ் பயஸில் அதிகமாக தான் இருக்கும். இந்த மாதிரி வரணும் அப்படின்னா என்ன சார் பண்ணுறது? திஸ் கேஸ் வில் நாட் பி பாசிபிள் இன் நார்மல் டயோட். நார்மல் டயோடை பொறுத்த வரைக்கும் ரெண்டு ரீஜன் தான். அப்போ இது எங்க சார் பாசிபிள்? Let us take, we will take the same one, but you have to draw separately. நீங்க தனித்தனியா வரீங்க. Okay, it's better. Let me also draw separately. Otherwise, you guys will mess it up. Okay. Arey, 1 minute. So let us take Zener Diode. What Zener Diode will do? Again, you can take same characteristics for Zener Diode. Forward bias, reverse bias, everything you can consider. What will happen is, in forward bias, Zener Diode also will be behaving like a normal diode. It means at a 0.7 voltage, it will turn on. So this is diode voltage and this is diode current. In forward bias, It is same as your normal PN junction diode. I am talking about Zener diode, but forward bias region of Zener diode is similar to normal PN junction diode. But in the reverse bias, you know what will happen? First, what will happen is, if when you are started injecting the negative voltage, Zener diode also will be carrying first going like this reverse saturation current. So once you reach the breakdown voltage, that is called Zener breakdown voltage. Zener breakdown voltage VZB. Once you enter into that zone, this is called Zener breakdown voltage. Once you enter into that region, என்ன சார் நடக்கும்? டயோடு வெடிச்சிரும். அப்படிதானே? No. இங்க தான் டயோடு வெடிக்கும். இங்க தான் டயோடு டேமேஜ் ஆகும். In Zener diode, diode will start functioning. It started carrying enormous amount of current with the Zener breakdown voltage. Nice, sir. Basically, what will happen here then? So I have highlighted that if you take normal PN junction diode in forward bias, it will be represented like this. Either it will be short circuited or 0.7. Short circuited means ideal case. 0.7 means practical case. Whereas in the reverse bias, it will be always open circuited. You have to remove the diode by its equivalent open circuit. When you take Zener diode, I am talking here. I will keep it here. If we are taking this superstar Zener diode, basically what will be happening here is, in forward bias, just now we saw, first of all, the representation of the Zener diode I will be keeping here. Sir, why it is represented like this? Because Zener diode can be operated in both forward and reverse direction, dual operation. So the direction of the current can go from anode to cathode, as well as it will also come from cathode to anode. Both direction could be possible. See, the direction will be indicated like this, that zone. It will be indicated like this only. It means what? Current can flow in this direction, current can also flow in this direction. Just you can take like that. Don't go too much depth. Fine, sir. So in forward bias, as usual, this is anode, this is cathode. If you take the forward bias, we know in forward, let me take, this is anode, this is cathode. So in forward bias, anode will be replaced by positive plate, cathode will be replaced by negative plates, and its correspondent voltage will become 0.7 voltage. So it is similar to normal PN junction diode. When we are entering into reverse bias region, in reverse bias region, what will happen? Almost it will be acting as a open circuit, but leakage current will be there. So there will be one more region, that is called breakdown region. In reverse bias region, actually what will be happening here is very minor amount of leakage current will be flowing. But basically it will be behaving as a open circuit only. Minor leakage current means almost it will be in nanoampere. Nanoampere means, you know, 10 power minus 9. Approximately that current will be 0. But when you are entering into breakdown region, what will be happening here is, in breakdown region, remember, anode will become negative, cathode will become positive. So what we have to do? Anode plate will be represented by negative, cathode plate will be represented by positive. It will be like this. Don't forget this, anode to cathode. So there will be some internal specification for your Zener breakdown region. When we are keep on injecting the voltage in the negative side, what will be happening here is, the amount of minority charge carriers level is continuously increasing, and all majority charge carriers will go out. Basically, how we are highlighting this positive and negative plate? Suppose, see, I am telling that I am designing the diode with the help of PN junction, P and N. P indicates positive, N indicates negative. That's why from anode to cathode we are putting plus to minus. This will happen in the forward bias. When you are entering into reverse breakdown region, first what will happen is, let me tell you, first we are traveling in reverse bias. Reverse bias la first enna agadina, initially your Zener diode will be operated in the reverse bias region. Upper reverse bias la vandu enna agadina, you know what will happen in reverse bias? All positive charges will go out from the P plate, all negative charges will go out from N plate. So P la irukka ella majority charge carriers velila poidum. N la irukka ella majority charge carriers in the sense negative charge carriers. In N layer, we will have more negative charge carriers where less positive charge carriers. In P layer, we will be having more positive charges, less number of negative charges. So in reverse bias, what will happen? This all charges will go out. I am talking about majority charge carriers. Then who will be there? If all majority charge carriers will going out, only minority charge carriers will exist here. Only minority charge carriers will exist here. In positive layer, the minority charge carrier. Minority means less number of charges. So we will be having in positive layer, we will be having less number of negative charge carriers. In negative layer, we will be having less number of positive charge carriers. So this is what will happen in the reverse bias region. When we are entering into reverse bias breakdown region. So in reverse breakdown region, what will be happening is, anyway, we are continuously operating. We are continuously pushing the diode to operate in this way only. நம்ம reverse biasல தானே continuously அதை operate பண்ண try பண்றோம். இப்போ என்ன ஆகும் அப்படின்னா, in reverse bias, we are doping. We are increasing the concentration of the negative charge carriers in P layer, and we are increasing the concentration of positive charges in the N layer. It means what will be happening here is, reverse biasல negative charges வந்து N layerல இருந்து வெளியில போயிட்டு இருக்கு அப்படின்னா positive charge carriers உள்ள வந்துட்டு இருக்குன்னு அர்த்தம். Similarly, in the P layer, if all positive charges are going out, it means indirectly negative charges are coming inside. So what will be happening? இது continuous நடந்துட்டே இருக்கும்போது ஒரு டைமுக்கு அப்புறம் என்ன ஆகும் அப்படின்னா, in our P layer, we will be having more number of negative charge carriers, and in the N layer, we will be having more number of positive charge carriers. அப்போ reverse breakdown regionல diode turn on ஆக ட்ரை பண்ணும்போதெல்லாம் என்ன ஆகும் அப்படின்னா, completely your cathode will become positive and anode will become negative. That's why we are representing it like this. So cathode will be represented by positive plate, anode will be represented by the negative plate. So this is the basic of Zener breakdown region. This is the beauty of Zener diode. And its voltage level will be 10, 5, 15, 20 like that. So this reverse breakdown region basically we are using. இந்த இடத்துல என்ன அப்படின்னு பார்த்தீங்கன்னா, this reverse breakdown region voltage will become constant. இது அப்படியே fixed. Diode வந்து turn on ஆயிடும். Reverse biasல turn on ஆயிடும். Breakdown regionல current value will be going from minimum value to maximum. It will go from IZ minimum, you can call Zener minimum current to Zener maximum current. It will tries to go from minimum value to maximum current, but voltage level will be fixed. And you know how to highlight the polarity also. I hope every one of you understand what's happening here. So the conclusion is, this zone will be basically used for the purpose of regulating the voltage. Where we are going to regulating the voltage, sir? The voltage fluctuation அப்படின்ற ஒரு கான்செப்ட் வந்து படிச்சிருப்பீங்க. What is the meaning of voltage fluctuation? நம்ம வீட்டிலலாம் பார்த்தீங்கன்னா திடீர்னு வந்து லைட் வந்து பிளிக்கர் ஆக ஆரம்பிச்சிடும். நைட்டில் வீட்டில் ஏதாச்சும் சேர்ந்து இந்த அமானுஷ்ய சக்தி வீட்டில் வந்து அதை நடக்கும்னு சொல்லுவாங்கல்ல, அந்த மாதிரி பல்ப் வந்து டக்குன்னு பிளிக் ஆக ஆரம்பிச்சிடும். சவுண்டெல்லாம் ஒரு ஒயின்னு சவுண்ட் வரும், டக்குன்னு பிளிங்க் ஆகிட்டே இருக்கும். யூனோ why it is happening like that? It's because of the voltage fluctuation. Voltage fluctuation அப்படின்னா, இப்போ நமக்கு வீட்டுக்கு வந்துட்டு இருக்க வோல்டேஜ் வந்து 220 வோல்டேஜ் வச்சுக்கோங்க. இது ஃபிக்ஸடாக இருக்கும். நம்ம வீட்டில் இருக்க எல்லா லைனுமே பேரலல் லைன் தான். நம்ம லோட்ஸ் எல்லாமே பேரலா தானே கனெக்ட் ஆயிருக்கு. ஸோ கான்ஸ்டன்டா வந்து நம்ம டிரான்ஸ்ஃபார்மர்ல இருந்து 220 வோல்டேஜ் தான் எல்லா லோட்ஸ்க்கும் கனெக்ட் ஆயிருக்கு. என்டையரா ஒரு 1000 ஹவுசஸ் அங்கே இருக்கு அப்படின்னா 1000 ஹவுஸ்க்கு வந்து ஒரே சிங்கிள் வோல்டேஜ் தான். இட் வில் பி கனெக்டட் பேரலி. 220 வோல்டேஜ் இஸ் ஃபிக்ஸட் ஃபார் ஆல் அப்ளிகேஷன்ஸ். ஆஃப்டர் தட் பேரலல் லைன்ல வந்து நம்ம வோல்டேஜ் ஸ்டெப் டவுன் பண்ணி யூஸ் பண்றோம். தட் இஸ் another cases. Just to fix it like this. இப்போ இங்க என்ன ஆகும்னா, suddenly if this 2000 voltage is dipping to 210 for 2000 205 இந்த மாதிரி வந்து வோல்டேஜ் டிப் ஆகுது அப்படின்னா, that is called voltage fluctuation. It is dipping 210 போயிட்டு திரும்ப 220 வரும், again 210, again 220. So that is called fluctuation in voltage. So இது எதனால நடக்கும் அப்படின்னா, வோல்டேஜ் டிப் ஆகுறது. சடனா எங்கேயாச்சும் ஷார்ட் சர்க்யூட் ஆயிருக்கும் லோட்ல ஏதாச்சும் ஒரு இடத்துல, இல்லைன்னா சடனா வந்து வோல்டேஜ் டிராப் வந்து ஏதாச்சும் ஒரு இடத்துல அதிகமா இருக்கும் லைன்ல. So there are so many reasons for that. So basically this is called voltage fluctuation. இந்த மாதிரி வோல்டேஜ் ஃப்ளக்சுவேட் ஆகும்போது நம்மளோட லோடு வந்து டேமேஜ் ஆகக்கூடாது அப்படின்னா, வாட் வி ஹாவ் டு டூ இஸ், சப்போஸ் லெட் அஸ் டேக் மை லோட் ரேட்டிங் இஸ் ஜஸ்ட் ஐ எம் டேக்கிங் சம் 50 வோல்டேஜ். நான் வோல்டேஜ் வந்து ஸ்டெப் டவுன் பண்ணி வச்சிருக்கேன். அகைன் ஐ எம் யூசிங் அ ஸ்மால் டிரான்ஸ்ஃபார்மர் இன் அவர் சர்க்யூட். இப்போ நம்ம டிவிக்கு தேவையான வோல்டேஜ் வந்து லெட் அஸ் டேக் லேப்டாப் எடுத்துக்கலாம். நம்ம யூஸ் பண்றது லேப்டாப் 19 வோல்டேஜ் இதுக்கு தேவை. ஸோ பேட்டரியில் வந்து என்ன பண்ணியிருப்பாங்க அப்படின்னா 220 வோல்டேஜ் வந்து சப்ளைல இருந்து எடுத்து it will be connected like this. See there. This is called stabilizer, voltage limiter. நம்ம எல்லா வேல்யூவும் கொண்டு வர முடியாது இல்லையா? By adjusting this value, suppose if I am having 220 voltage here. So by adjusting the proper, இந்த ரெசிஸ்டர் வந்து கரெக்டாக ஃபிக்ஸ் பண்ணி நம்ம என்ன பண்ணிக்கலாம் அப்படின்னா இந்த பாயிண்ட்ல வந்து கரெக்டாக 19 வோல்டேஜ் வரா மாதிரி ஃபிக்ஸ் பண்ணிடலாம். ஃபர்ஸ்ட் கொண்டு வந்ததுக்கு அப்புறம் என்ன பண்ணுவாங்க அப்படின்னா here we will be connecting a Zener diode in reverse breakdown regionல கனெக்ட் பண்ணிட்டு அதோட ரேட்டிங் வந்து 19 வோல்டேஜ் ஃபிக்ஸ் பண்ணிடுவாங்க. Zener diode வந்து மேனுஃபேக்சரிங் பண்ணும்போதே 19 வோல்டேஜ்ல வந்து அது டர்ன் ஆன் ஆகுற மாதிரி ரிவர்ஸ் பிரேக் டவுன் ரீஜன்ல அது ஆன் ஆகுற மாதிரி ஃபிக்ஸ் பண்ணிடுவாங்க. Now we know where is our laptop. So here I am going to give the connection to our laptop. So what we have to do here? So this is our laptop portal. இதுக்கு எவ்வளவு வோல்டேஜ் இன்ஜெக்ட் ஆகணும்? Only 19 voltage I am demanding. So when the moment the voltage will be received here, இப்போ இங்க என்ன நடக்கும் அப்படின்னா automatically we are receiving 19 voltage, so this Zener diode will turn on in reverse breakdown region only. See there, this is plus, this is minus. You know when it will happen? Basically this is called anode, this is called cathode. Cathode positive plate ஆகும், anode negative plate ஆகும் ஆப்ரேட் ஆகுதுனாலே அது என்ன region? That is called reverse breakdown region. Just now we saw. I told when cathode will become positive, anode is going to be negative. I have explained the entire process, how it is happening. So Zener diode must be operated in the breakdown region only. நார்மலா ஒரு இடத்துல வந்து உங்களுக்கு ஃபார்வர்ட் பயாஸோட கேரக்டரிஸ்டிக்ஸ் தேவை அப்படின்னா you can go with the normal PN junction diode. ஃபார்வர்ட் பயாஸ்ல மட்டும் நீங்க ஆப்ரேட் பண்றதா இருந்தா you can go with the normal PN junction diode. Reverse bias, normal PN junction diode. So the special application, wherever there will be a need of regulation, voltage regulation, there you can give the priority to this Zener diode. So அப்ப இங்க என்ன நடக்கும் அப்படின்னா see there, what will be happening is when we are receiving 19 voltage here, this Zener diode will turn on and cathode will become positive, anode will going to be negative. That 19 voltage will be highlighted like this. Now this voltage will be fixed or not? Yes, it is fixed, sir. So this 19 voltage is fixed. So now check. Suppose if this 220 voltage is fluctuating, suddenly it is dipping to 210 voltage. Is there any problem here? No. To turn on my Zener diode, I need only 19 voltage. So because of this voltage fluctuation, see it is only reducing to 210, but I need only 19 voltage. I need only 19 voltage. So this voltage fluctuation does not affect your load property. It will be remains safe. It will be operated in the safe region. Now there will be no any fluctuations in the load. It will be operated in the safe operating. So it will be operated in the safe zone. That is called safe operating area. Power electronics la indha mari area நம்ம படிச்சிருப்போம். Basically in power electronics we will be defining it with respect to heat. Temperature வந்து ஒரு பர்டிகுலர் லிமிட் வரைக்கும் இருக்கிற வரைக்கும் டிவைஸ் வந்து சேஃபா இருக்கும். தட் இஸ் கால்டு சேஃப் ஆப்ரேட்டிங் ஏரியா. அதை தாண்டி நீங்க கரண்ட்டை வந்து இன்ஜெக்ட் பண்ணாலோ இல்ல வோல்டேஜ் வந்து இன்ஜெக்ட் பண்ணாலோ டிவைஸ் வில் கெட் டேமேஜ். So basically safe operating area means it is talking about maximum voltage and maximum current in x and y axis. And if we join this is called safe operating area. Okay, so like that here also we will be designing the maximum voltage and the maximum current. Fine, sir. So anyway, what we understood here, in order to avoid this voltage fluctuation, the priority will be always given for Zener diode. So we understood everything about the Zener diode. Almost I had given all sufficient thing. Now this Zener diode basically carrying two type of current. If you take this Zener diode, I told when Zener diode will be slowly turn on in reverse bias, in reverse breakdown region, it will be carrying a current. I can write like this: Zener minimum current to maximum current. It will carry minimum current to maximum current. So what we have to do is, during this condition, you have to check whether the Zener diode is carrying minimum current or maximum current, and the voltage drop across the Zener diode, that is called breakdown voltage, Zener breakdown voltage. This voltage will always be given in the examination. Now you will be requested to calculate the maximum or minimum power consumed by the Zener diode. If they are asking like this, maximum power means you have to select Zener breakdown voltage is fixed. Whereas whether the Zener diode is consuming the maximum power or minimum power, that will be decided by your current. If you are taking minimum current, then power will be minimum. If you are taking maximum current, maximum possibility, then your power also will become maximum. So in the examination, if they are asking you to identify the maximum power consumed by the Zener diode, you have to identify the maximum current carried by the Zener diode. Remember one thing, now the current will be going from cathode to anode, not anode to cathode, and we have also highlighted the polarity very clearly. So this current is called Zener current. Now you have to decide whether this Zener current is maximum or minimum according to the given question. Okay, I hope you all understood. So this is all about Zener diode. So whenever Zener diode will be given, 98% it will be operated in the reverse bias region only. There will be some cases it will also be operated in the forward bias. In forward bias, you know what to do. You can, in forward bias, treat your Zener diode as the normal PN junction diode. Just turn on and keep 0.7 voltage across it and proceed further. Anode is positive, cathode is negative. Current will be going from anode to cathode in case of forward bias. That is all about Zener diode. Whereas they are also talking about the power dissipation in the transistor. In your question, I have noticed that they are also talking about the power dissipation in the transistor. Sir, which voltage I have to take, which current I have to take? In transistor, we are having base voltage, collector voltage, emitter voltage, base current, collector current, emitter current. Which things I have to consider? You know, transistor will be operated, or transistor operating region will be always desired with the help of only two person. One is collector to emitter voltage, another one is collector current. That's all. So if you multiply these two, that will give you the maximum power dissipation in any region. If you are in active region, multiply these two, because we are deciding the transistor zone just with the help of these two people only. That's why they are called operating point. You all know, right? This is called operating point or cutoff point. So with the help of this operating point only, we are deciding the region of operation, whether it is an active region or saturation region or cutoff region. Yes, fine, sir. So being a power dissipation, once again, if they are talking about maximum power dissipation, then they give this chance. Try to observe the maximum collector current, because this collector to emitter voltage also will be fixed. If it is in saturation region, then it is 0.2. If it is in active region, then you have to go with the collector current maximum possibility. According to that, you can find out this voltage. So that is how we are finding the power dissipation of the transistor and the power consumed by the Zener diode. Shall we start the operation now? Everything is given. Now go back to the question. Let us take the question. In the question நான் இவ்வளோ spend பண்ணல. Zener diode வந்து maybe some of you not aware of it. That's why I just taught you how to do that. Shall we take the question now? Yes. So let us take the question, and I will be redrawing the question and for your understanding. இப்போ இங்க என்ன ஆக போகுது அப்படின்னா, see that this Zener diode will going to be operated in the breakdown region. First conclusion. See, the direction of the current is given, that is called the Zener current. Current entering point. This is plus, this is minus. Always cathode will become positive, anode will become negative in breakdown region. So we can indicate that. Okay, sir, no issue. Next, they told that this RB is not going to carry any current. Read the question. The transistor shunt regulator. This is called transistor shunt regulator circuit. Shown in the figure, regulated output voltage equal to 10. They told that the value of output voltage is 10. It is already fixed. Next, the value of input voltage is given. The relevant parameter for the Zener diode and transistor. See, Zener voltage. See, the value of the voltage is 9.5. I told you this voltage will be there. What? When this applicable? Voltage range is in, sir, it is very high voltage. In forward bias, the voltage drop across the diode is only 0.7. If it is given as Zener voltage, means it is what? Breakdown voltage only. So the breakdown voltage is 9.5 in the sense, in the breakdown region, the voltage drop across the Zener is given, that is 9.5 voltage. Next, they also given base to emitter voltage. You know, this is transistor. Base to emitter voltage is given as 0.5. Then they also given the value of beta here. Beta equal to 99. Neglect the current through the RB. See that? They only told that current through the RB will become 0. This resistor. They are neglecting this current. Then what is the maximum power dissipated in the Zener diode and the transistor? You know the formula, everything. Now the only thing is we have to proceed further. Let me redraw the circuit according to the given data. See, when there will be no current flow in this RB, what is the voltage drop? The voltage drop will become, according to Ohm's law, I into R. I value is 0. So 0 into RB will become 0 only. So 0 voltage. So the voltage drop across this resistor will become 0. Anyway, first of all, current flow through the circuit is 0 ampere and voltage also 0. This is useless. I am not going to consider this branch now. So I will be simply redrawing the circuit for your better understanding. Start from the input, draw the resistor, then Zener Diode will going to be operated in the reverse breakdown region. So you know cathode will become positive, anode will become negative, and this voltage value is clearly given as 9.5. Then it will be directly connected with the transistor. Yes. And they also told that between base to emitter they are having 0.5 voltage and it will be connected with the ground. See, I am removing that resistor RB, that is useless. There is no any current flow. Whatever the current that is coming through the Zener, that is called IZ. If the same current is entering into base, then IB and IZ both are will become same or not. See, both are connected in series. Whatever the current that is coming from here, same current will be entering into base also. Next, let us continue further. Sorry. Yes. So now, if you take the transistor, what they did here, these two terminals they have connected together, and they told that this region, this is negative to minus, this voltage is V0. We all know, see there, this is called VCC. Yes or no? Yes, sir. This is VCC. And the voltage between collector to emitter, that is called VCE. We are calling it as, because this point is called collector point, this point is called the emitter point, and the voltage between collector to emitter is VCE. Now tell me, between VCC and VCE, do you have any resistor in this branch? No, sir. So collector resistance RC is 0 because it is short circuited. If RC is 0, then I can simply say VCC and VCE both are same or not? Yes, sir. VCC is basically called V0. Yes or no? We are measuring the voltage between this and this terminal. This means same terminal only, ground. So between this we have only one voltage then. VCC, V0, VCE all are same only. Because there is no any other voltage. Emitter resistance also not there, collector resistor also not there. So I can call that the value of V0 is equal to collector to emitter voltage VCE, that is fixed. Next conclusion. I am observing here, that's all. Next to the input resistor, here they told this value is 20 ohm. And they also what did here is they have connected one DC supply. I am drawing it separately. And they told there is some range for this voltage. So let me keep, I'm simply calling it as input voltage. Now what they told is the input voltage is lies between 20 to 30. Forget, yes, it is 20 to 30. So this voltage is lies between 20 to 30 voltage. So this is, we know this voltage is called input minimum voltage and this voltage is called input maximum voltage. So now how should I proceed further? Yes, let us see what to do now. Let us make some conclusions here. Now they told that the value of output voltage is 10 voltage in the question is given. Yes or no? Observe the question. I have collected now. Output voltage is fixed at 10 voltage. In the question they did this circuit shown in the figure. The value of V0 equal to 10 voltage. They told when the input is lies between the range of 20 to 30. In this entire range, the value of V0 is 10 only fixed. It is, that is what given. So now what I am asking is, if that portion, if this zone is having 10 voltage, then what is the voltage at this point? Which point, sir? I'm just asking. Wait a minute. I'll be showing. I just wanted to know the voltage at this point. Can you please tell me? To know the voltage at this point, there are two ways. You can observe between this connected to, that is VCC, and this voltage. Let me call it as Vx. Between this, do you have any resistor? No, sir. So if there will be no resistor, then we know according to normal circuit, right? So this voltage will be reflected here also. So we know VCC, VCE, V0 all are same. Now at this point also we will be having same 10 voltage. You can also identify that voltage in the alternative way. What is the alternative way? See there. If you apply KVL for this loop, if you apply KVL till this point, just observe that. Actually what will be happening is from Vx, if you observe, We will be having a Zener diode. Then it is going and we are crossing the transistor. You know how to replace the transistor. Then it will be directly connected with the ground. And they told that this voltage is 0.5 voltage base to emitter voltage and Zener voltage is 9.5. Now see there, I just wanted to know the voltage at this point. Here we will be having 0 voltage. So now let us take current always flow from higher potential point to lower potential point. First of all, these two elements, see there, positive plate and positive plate are in the same direction. Like positive plate, it is placed at the top. Here also on the top only positive plate is placed. It means these two voltages are aiding each other. Aiding in the sense addition. So you can directly add 9.5 plus 0.5 will become 10 voltage. So this entire circuit will be simply draw like this. We can draw this now like this. So here we will be having 10 voltage. Then what is the voltage at this point? Tell me. Here we are having 0 voltage. Now we know positive plate will be reflected here, this negative plate. You know, if negative plate is reflecting here, then that is called a lower potential point. Where is the positive plate is reflected? This positive voltage is reflected here. That is called higher potential point. So higher potential minus lower potential will be equal to drop across the branch. So from this I can say the value of Vx equal to 10 voltage only. So this is the alternative way to identify the value of Vx. Anyway, we found the value of Vx, first conclusion. Next, they told that we have to identify the maximum current consumed by the Zener diode. Sir, how should I do that? Now you have to think. First, already we made one conclusion. I told that the value of Zener current and base current both are same because both are connected in series. Sir, then where is that RB? RB அங்க தான் இருக்கு. RB useless இருக்கு. ஏன்? அவங்க தான் சொல்லிருக்காங்க RB ல கரண்டே போகலன்ட்டு. So you can neglect it. So the value of Zener current and base current both are same. Then what should I do now further? They told that in both cases I have to identify the maximum power dissipation. அப்போ maximum power இங்க dissipate ஆகணும் அப்படின்னா you have to consume maximum collector current. Yes sir. Maximum Zener current. Yes sir. அப்போ இவங்க ரெண்டு பேரும் maximum ஆகணும் அப்படின்னா basically we are consuming this current from the supply only. So from the supply you have to consume the maximum current. Yes or no? In order to let these two people to consume the maximum current, from where that currents are coming? These currents are coming from the input only. So from here you have to maximize the current. So supply current must be maximum. Where I will get the maximum supply current? According to Ohm's law, we know voltage is directly proportional to I. Yes sir. So if you want to maximize the input current, if you want to maximize the input current, then you have to maximize the input voltage also. Yes or no? So if you want to, in order to achieve the maximum supply current, I have to supply the maximum voltage from the input side. Supply voltage or input voltage, whatever. I am calling it as input voltage. So you can also take input better. So maximum input voltage is required. Whereas the input voltage range is given as 20 to 30. The maximum means I have to take 30 voltage. That is the conclusion. So to solve this entire question, supply voltage is going to be fixed as 30 voltage. Next conclusion we made it here. Yes or no? I hope you all understood this. Now let me remove these unwanted things. I have explained everything clearly. Yes sir. Now it's time to identify the current. Shall we start? Yes. Let us start the operation. So we have taken everything. Input voltage is fixed. Now you can do it by yourself also. Just to solve the question. Everything is identified already. So don't bother. Whenever you are seeing Zener diode, your question will be very, very easy. Zener diode mostly it will be operated in this breakdown region only. Just to replace it by its equivalent circuit and substitute the voltage drop. That will also be given in the examination. Don't worry. Voltage drop for the Zener diode will be clearly given by them. So you don't need to do anything. So your only task is just to solve the question. Start pannalama. So let me try to solve this question now. Yes. See, at this point, if you observe, plus 30 voltage will get reflected. This 30 voltage, it will be reflected here. Here already we are having 10 voltage. So now what is the maximum supply current? Already I have highlighted here. How will you identify the maximum supply current? the maximum value of supply current will be equal to maximum supply voltage, that is maximum input voltage. Current always flow from higher potential point to lower potential point. If you keep your attention with only the 20 ohm resistor, just observe it. How it is? We are having a 20 ohm resistor from the input side. One side we are having 30 voltage. In the another side we are having 10 voltage. So current will be directed from higher potential point to lower potential point. First conclusion. So here we are having 30 voltage. Here we are having 10 voltage. So 30 minus 10 is what? 30 minus 10 will be, see, this is Vx. That is the voltage drop across the resistor. 30 minus 10 will be 20 voltage. So I can write it divided by, if you put the resistor value, you will be getting the current. 30 voltage minus 10 voltage will give you 20, divided by the value of resistor is 20. 30 minus 10 will be 20. 20 by 20 will be 1 ampere. So the value of current will become 1 ampere. So once you find the maximum current, what is our next target? Let us try to achieve the value of IZ, that is a Zener current and collector current. Now see, this is the collector current IC. This current will be coming from here only. Now if you apply KCL at this junction, you will be getting two current. Let me write here. The supply current, maximum supply current that is coming, that will be equal to, if you apply KCL, it is the addition of Zener current plus collector current. Yes or no? We all know Zener current will be equal to base current. Yes sir. And collector current can be replaced by beta times of base current. Yes or no? Yes sir. So from this I can take base current outside and you can write 1 plus beta. Sir, this base current equal to Zener current only. You can also write IZ into 1 plus beta. Don't get confusion with this. And the supply maximum current is 1 ampere we know. So I can say 1 ampere equal to Zener current is not known into 1 plus beta value is already given, that is 99. Substitute here. From this I can say the value of Zener current equal to 1 upon 100, or I can say 1 into 10 power minus 2, or I can say 10 milliampere. You know how to write this. Okay sir. So what we found here, value of Zener current, that too you have to observe, this is maximum value. Don't forget. How we achieved this maximum value? By maximizing the supply current we achieved this. So this Zener current is known as base current. Under base current we are achieving the maximum current only. Minimum current will be in microampere. Base current always, we know that. So here also we are also operating the Zener diode. So it will be in milliampere. Fine sir. Once you achieve the base current, then how will you achieve the what I can say, collector current? So IC maximum, that can be achieved with the help of collector current IC equal to beta times of maximum base current. Just now we found that the value of maximum base current is 10 milliampere. So 99, beta value is 99 into 10 milli. Milli means 10 power minus 3. So I can say it will be 990 milliampere, or you can also call it as 0.99 ampere. That's all. So we found the value of collector current also. Now it is time to explore the value of other people. What other people, sir? Power dissipation. They are asking maximum power dissipation of this Zener diode. That will be equal to Zener breakdown voltage into maximum Zener current. Okay, sir. So Zener breakdown voltage, I think it is 9.5 into current flow through this Zener diode. Maximum current is 10 milliampere, that is 10 power minus 3. So 9.5 into 10 will become 95. So 95 into 10 power minus 3, or we can consider it as 95 milliwatt. Completed. So this is the maximum power consumed by the Zener diode. One question is over. Now what is the another question? We have to identify the maximum power dissipated in the transistor. You know how to identify that. You know the formula. When we are considering the transistor, what is the maximum current? For the transistor, it can be written as collector to emitter voltage into maximum collector current. Yes, we found that one also. So the collector to emitter voltage is 10, whereas maximum collector current, what we found is 0.99 ampere. So this will become 9.9 watts. Yes sir, that is maximum transistor power. So we found both. Sorry. Yes, that is the maximum power that is dissipated across the transistor. So the correct answer is 95 comma 95 milliwatt comma 9.9 watt. We got the answer. These two. I hope you all understood this question. Understanding the question is not a big matter. The thing is, you have to learn all these things, how to solve this type of question when it is being asked in the examination. இது வரைக்கும் நம்ம பார்த்தது ஒரு whole theory. கொஸ்டின்ல ஒரு டேட்டா கொடுத்திருந்தாங்க ஞாபகம் இருக்கா? Transistor shunt regulator. So that is the beauty of analog. It doesn't. இதை பத்தி உங்களுக்கு ஏதாவது தெரியுமா? Tell me now. ஏதோ ரெகுலேட் பண்ணுதுன்னு தெரியும். இதை பத்தி உங்களுக்கு வேற என்ன தெரியும் இந்த சர்க்யூட்டை பத்தி? Nothing. எதுவுமே தெரியாது. You haven't studied any theory, but you will be solving the question now. இப்போ இந்த மாதிரி கொஸ்டின் கேட்டா definitely you will be solved. You will be able to solve. Normal circuit theory basics are sufficient to solve almost 99% of the analog electronics questions. That's what I would like to conclude every time. So it's better to solve as many questions as possible just with the fundamental basics. That is sufficient. Chalo sir, let us go ahead with the next question. Yes. So the next question is, take a transistor. This is given. Again, here also we have a resistor. It is connected with the ground. Okay, sir. Next, here we will be having one more resistor. Yes, it continues. Again, we have one more resistor. These both are connected together. They are joining these two, and these two also join it together. And they told here they are injecting 5 voltage resistor. This is 2.2 kilo ohm resistor, 5 voltage source, that is 2.2 kilo ohm resistor. This is always 4 kilo ohm. This is 1 kilo ohm. This value is 300 ohm, they told, and they are calling this is, we know what is this, collector to emitter voltage. So everything is given. Now in the question, assuming that the beta of the transistor is extremely large, they are telling that this is extremely large. You know the meaning of extremely large. Whenever it is given that it is extremely large, what is the actual meaning? The value of base current will become 0 approximately. And they also told that base to emitter voltage is 0.7 voltage. And now the question is, IC and VCE in the circuit shown in the figure. Actually the question is, operating points are dash. Identify the operating points. You know which element, which term is called operating point, and you also know how to solve this type of question. If your base terminal is simply connected with a single resistor, then that will be fine. When we are having two resistors, then what we have to do, you have to Thevenize the circuit, find out the Thevenin voltage, Thevenin resistor, then proceed further. Take your time. I will be giving 3 minutes. You can also take beyond. Okay, first take 3 minutes. Try to figure out the answer. I'm expecting it to be done from your end. I will be very happy if you people do this, because very easy question. Do it. If any one of you will get the answer immediately, drop it in the comment section. Actually, I'm waiting for your answer. Just try. Every time my mind is thinking whether you people are sleeping or studying. This is what used to happen in offline classes also. Early morning classes going at 5 a.m. For most of the people, this is called a late night, 5 o'clock. I used to ask, even நம்ம ஆஃபீஸில் பேசிகிட்டு இருக்கும்போது கூட if I say 5 o'clock, 4 o'clock, they immediately started rolling their eyes like this. சடனாக கேட்கும்போது ஐஸ் வந்து ஒரு 10 மடங்கு பெருசாகிடும். தலையே சுருங்கிட்டு அந்த கண்ணு மட்டும் வெளியில் வந்து தெரியும். அப்படி மாறிடுவாங்க. Why? That is called a late night. It's too difficult to study at that time. It's if you are in that case, then try to manage and solve the question, but don't sleep. That's not good. Fine, I'm not going to solve this question first of all because already we have solved one question in the same model. It is there in your note, but I'm giving the clue what you have to do. First of all, they told that your circuit will be having extremely large value of beta. In that case, basically emitter current is written as it is the sum of collector current IC plus base current IB. But when the value of beta is very very large, if it is extremely large, then what can we do? This emitter current IE will going to be approximately equal to the value of collector current IC. You know how to bring this relation. So I can say the value of base current approximately it is equal to 0 ampere. Actually that value will be there. It is NPN transistor. Actually that value will be there. So but it is equal to 0 approximately. Remember this. Then they told that the value of base to emitter voltage is going to be 0.7. Everything is fine, sir. Operating point means we have to calculate the value of collector to emitter voltage and collector current. These 2 points are simply called cutoff point or operating point. Why? Because these 2 points only decide the region of operation, whether either your transistor is in active region or it is in saturation region or it is in cutoff region. These things will be basically decided with the help of our supreme stars, collector to emitter current and voltage and collector current only. Fine, sir. Anyway, there will be no any direct clue, and I have also told you that whenever you are observing two resistors in base junction, if a single resistor is not directly connected to your base terminal, then take this point, Thevenin's the circuit. How will you Thevenin's? We have to treat our entire transistor as a load according to Thevenin theorem. Just to treat your entire transistor as a load. Then you can draw the circuit like this. See there. On the top, the supply voltage 5. It is common for both transistor and base terminal. So here I am breaking this into two off. I am keeping 5 voltage here also and I am keeping 5 voltage here also. Anyway, this entire zone will be treated as a load. So I am removing while applying Thevenin theorem. So when the moment you are applying Thevenin theorem from the base terminal, I am just Thevenizing the circuit. According to Thevenin theorem, what we have to do? Step number 1, identify the load terminal. Base is our load terminal. Step number 2, actually we have to identify the load. Step number 1 is identify the load. Step number 2, remove the load from the load terminal. So from the base, I am removing the entire transistor. So I am considering only a remaining portion of the circuit. It will be drawn like this. Yes, sir. And here they told this value is 1 kilo ohm. I hope this is 4 kilo ohm, right? And here they have given 5 voltage and this terminal will be treated as base terminal. From here only we have Thevenized the circuit, so we have to calculate the value of VTH and RTH from this port only. Now how will you calculate the value of VTH? See, VTH is nothing but base. Across the base only we are measuring between these two terminals. Negative means it is connected to the ground. See that. Then this positive voltage will be reflected here. Ground means you can join these 2 points. Negative voltage will be reflected here. So VTH is known as the voltage drop across the 1 kilo ohm resistor. How will you calculate it now? We know base current is going to be 0. We have already theveninized the circuit. Load terminal is open. Base current அவங்க கொடுத்திருந்தா கூட 0 தான் இப்ப. Why? Because when we are thevenizing the circuit, basically load terminal will be open circuited. When load will be open circuited, then current that is going through the load will become 0 ampere. So there is no point of worrying about the current flowing through this branch. It will be always 0 when you are thevenizing the circuit. So directly, in that case, what will happen? This 4 kilo ohm resistor and 1 kilo ohm resistor will be connected in series. Whatever the current that is coming from this 5 voltage source, it will be directly going through 4 kilo ohm and 1 kilo ohm resistor and reaching the ground. So it clearly indicates that these two resistors are connected in series. I can say the value of Thevenin voltage VTH equal to total supply voltage into voltage drop across the 1 kilo ohm resistor divided by 4 kilo ohm plus 1 kilo ohm total resistor 5 kilo ohm. Kilo will get cancelled. 5 will get cancelled. We are getting 1 voltage. So what we understood? Thevenin voltage will become 1. From this I can say the value of Thevenin voltage will become 1. Thevenin voltage also called what? Base input voltage. So this voltage will be 1 voltage. This is same thing I did in the last question. Last question in the sense, previously already we saw the same model type. Now how will you calculate the RTH? To calculate the value of RTH, we have to do one more thing extra. Basically, while dealing with the VTH, we are not deactivating the independent source. But while calculating the value of RTH, all independent sources will be deactivated. So you have to connect this voltage source with the ground. Then what will happen? If this is also grounded, short circuited, here also we have grounded, here also we have grounded value. So we can interconnect these two ports such that the resultant network will become like this. A 4 kilo ohm resistor connected with the ground. And from the same node, I have 1 kilo ohm resistor that is also connected with the ground. So if both are connected with the ground, I can join these 2 points. See that this is going to be 4 kilo ohm. This is going to be 1 kilo ohm. From here only we are observing the RTH. RTH also, see, that is also connected to the ground, another terminal. This is positive, this is negative. From here only we are observing RTH. So it clearly indicates this 1 kilo ohm and 4 kilo ohm are connected in parallel from here. So I can say 4 kilo ohm into 1 kilo ohm upon 4 plus 1, 5. 5 kilo ohm. 1 kilo will get cancelled. 4 into 1 will become 4. So it will be 4 by 5 kilo ohm. That is the value of RTH. Basically, we all know Thevenin resistance is nothing but base resistance. After Thevenizing the circuit, we can reconnect the load. Actually, what is the load? Do you remember? Load. நீங்க எதை remove பண்ணீங்களோ அதுதான் load. Let me redraw the circuit. We have removed a 5 voltage source with a transistor. Wait a minute. Yes. Then complete நம்ம remove பண்ணதை அப்படியே எடுத்து insert பண்ணுங்க. That is called a load. This entire portion only we have removed. Yes. They told, I think, 1 minute. Yeah, this is 2.2 kilo ohm. This is 300 ohm. Collector to emitter voltage. This is collector current. Now circuit is Thevenized. This entire, whatever the circuit that we have Thevenized, we know how to connect it. Basically, VTH, RTH, then that is connected with the load. This is VTH, or we can call it as VBB. This is RTH, or we can call it as RB. Fine, sir. What is the amount? Voltage value is 1 voltage. Resistor is 4 by 5 kilo ohm. So this is 1 voltage. This is 4 by 5 kilo ohm. But this resistor is useless. Why, sir? Why? Because they told that the value of base current is 0 ampere. Approximately. How it is possible, sir? They only told beta is extremely very large. But base to emitter voltage is given, right? 0.7 voltage. Let me cross check once. Is it 0.7? Yes, it is 0.7 voltage only. Now it is very easy to identify the terminal. See, when current flow through the base is 0, what is the voltage drop across the base resistor? 0 into resistor is 4 by 5 kilo ohm. It will become 0 voltage. So there is no voltage drop across the resistor. So if you apply KVL for this loop, what you'll be getting? Here we are having emitter current IE. So current entering point plus leaving point is minus. So if you apply KVL for this loop, you will be getting minus 1 voltage plus voltage drop across the base resistor is 0 voltage. So I don't need to consider it. Then for the base to emitter voltage is 0.7. Then plus emitter current IE into its correspondent resistor. If you multiply these two, you will be getting the voltage drop of the emitter. So overall value will become 0. Minus 1 plus zero point 0.7 will be minus 0.3. If you pass the minus 0.3 to the right side, it will become plus 0.3. So I can write this emitter current IE into 300 equal to 0.3. So from this I can further write emitter current IE will be equal to 0.3 upon 300 can be written as 3 into 10 power 2. Can I write like this? And I will be bringing this 10 power 2 to the numerator. And you can cancel it. It will become 0.1. So finally, emitter current IE will become 0.1 into 10 power minus 2, or we can call it as 10 milliampere. We found the value of emitter current, and we know this emitter current is approximately equal to collector current according to the given data. So in the operating point, we found the one value. Now, similarly apply KVL for the outer loop from collector to emitter. See there, current entering point plus leaving point is minus. This is the direction of the collector current. On the top, you know how to represent this battery. Minus plus 5 voltage. Now, how will you write down the voltage drop for this 2.2 kilo ohm resistor? Collector current IC into resistor 2.2 kilo ohm. That is the voltage drop. Similarly, for the emitter also, you know, emitter current IE into resistor is 300. Now if you write down the KVL equation, again for this outer loop you will be getting minus 5 voltage plus collector current is 10 milliampere. Just now we saw 10 into 10 power 3 into resistor value is 2.2 kilo ohm. Kilo ohm means, see, this is minus. Kilo ohm means 10 power plus 3 plus collector to emitter voltage drop is unknown plus emitter current as usual 10 milliampere. 10 into 10 power minus 3 into the value of emitter resistance is 300 equal to 0. Now let us reduce the circuit. 10 power minus 3, 10 power plus 3 will become 1. 10 times of 2.2 will give you 22. So minus 5 plus 22 plus collector to emitter voltage plus here we will be having 10 into 300 will become 3000. 3000 can be written as 3 into 10 power plus 3. Already we have 10 power minus 3. So plus 3 minus 3 will become 1. So we have plus 3 alone equal to 0. Now 22 plus 3 will become 25. 25 minus 5 will be 20. Did I made any mistake here? We are getting wrong value. What did they ask us? We have to identify the region of operation. 1 minute. I think transistor is in saturation region, right? Okay, let's see. It's a beautiful question, guys. Yeah, let us proceed further. So 22 plus 3 will become 25. From this I can say minus 5 plus 25 will become 20. So what we are getting, the value of collector to emitter voltage will become minus 20 voltage. What is this? Is it possible? First of all, I'm just asking you. No, sir. But what is the conclusion that we can make here? The only conclusion that what we can make here is the value of collector to emitter voltage. The value of collector to emitter voltage is less than the value of collector to emitter saturation voltage. Good. So if the value of collector to emitter voltages is less than the saturation voltage, then the region of operation. Actually, I was assuming that the transistor is in active region. But my assumption is wrong. Why? Because I got negative value for the collector to emitter voltage. When the collector to emitter voltage is negative, what is this? In order to keep the transistor in the active region, the value of VCE must be greater than 0.2. So that is not happening here. So I can write the transistor is in saturation region. All my assumption are went wrong. Okay, sir. If the transistor is in saturation region, then we know the value of collector to emitter voltage is fixed. That will be 0.2 voltage. We know this value in the saturation region. So you can write the value of collector to emitter voltage is 0.2 voltage. First conclusion. Again start the operation from the beginning. Take the same circuit. Remaining all are correct, but you have to reanalyze, and once again we have to calculate the value of collector current. The current that we have calculated here, that is for active region. Now we found that the transistor is in saturation region. It is not in active region. We made the conclusion now. So our assumption is wrong. Again, assume the value of Vc equal to 0.2. Now it is fixed. Try to calculate the value of collector current. Again, apply KVL for the outer loop. What you will be getting? Minus 5 voltage plus collector current IC is not known now, into 2.2 kilo ohm resistor, that is 2.2 into 10 power 3, plus collector to emitter voltage is 0.2, plus, sir, we know emitter current can be written as collector current IC. So I am directly writing IC into 300 ohm equal to 0. Shall we reduce the circuit now? Yes, sir. See, minus 5 plus 0.2 will give you minus 4.8. Yes, plus 22. Here we have 22 into 10 power 3. This can be written as 2200. Here we have a 300. 2200 plus 300 will become 2500 times of collector current. So IC into 2500 will be equal to 0. Pass this minus 4.8 to the right hand side such that we can write 2500 into collector current IC equal to 4.8. Now, if you take the ratio between 4.8 upon 2500, what you will be getting? The value of collector current IC will become equal to 0.00192 ampere, or I can say the value of collector current IC equal to 1.92 milliampere. See, if you multiply it by 1000, what you'll be getting? You'll be getting 1.2, so it will be 1.92 milliampere. So that is how we are writing the value of collector current. So what we found? Two things. First one is transistor is being operated in the saturation region, and that is the first conclusion we found. Second one is operating point. What is the value of operating point? Operating point means collector to emitter voltage comma collector current. So the operating points are collector to emitter voltage is fixed, that is saturation voltage, comma 1.92 milliampere, because the region of operation is saturation. Don't forget, that is very important. I hope you all know this. See, when I was assuming the transistor is in active region, where is the collector current? So this is emitter current or collector current we have concluded here. Observe this. When the transistor is assumed to be in active region, we got the collector current value as 10 milliampere. I told now, in saturation region, the value of IC sat is always less than the value of IC. IC we got how much? 10 milliampere. Whereas for the IC sat we got 1.92 milliampere only. In this way also you can check whether the transistor will be in active region or saturation region. See there, if the IC set is less than IC, then the transistor will be operated in the saturation region. I told. So this is the alternative way to prove this. So let me check whether these things are correct or not. 1 minute. Key answer is not given for this question. I'm just looking for that. I don't know whether it is given or not. No, this key answer is not given, I think. Okay. See, there is no problem with this. Suppose while solving the problem, if you find there is any calculation mistakes done by me, just correct it by yourself, because there is no key for this question. Let me cross check once. If there will be any mistakes from our side, you can correct it. So this is minus 5, this is This is correct, and this is also correct. This is correct. Collector current, how much we got? This is, yeah, 10 milliampere. Here it is 0.3. Okay, 1 voltage means, yes, this is 0.3 only. Undoubtedly that is correct. Then 0.3 divided by 3.3 divided by 3 will be getting 0.1. Okay, I hope from our side there is no any mistakes. We did everything correct, right? So transistor is in saturation region only. Key answer is not given, so you can just fix it. Anyway, we did not do any mistakes. We concluded everything in the proper way only. Just take it. Okay. Chalo. They have given a transistor. Okay. It is directly bypassed to the ground. Then they have taken a feedback line, and it is connected like this. Okay. Then they said this is called a collector current. We also know that is called a collector current. And they are telling that this is called a base to emitter voltage. Yes, of course, we know that is correct. Now what they are telling is, given it is NPN transistor, okay sir, that is NPN transistor, base to emitter voltage given. See, they are telling that given NPN transistor having base to emitter voltage equal to 0.7 volt, and the reverse saturation current for this, the reverse saturation current, I'm calling it as reverse saturation current, 10 power minus 13 ampere. So that is 0.1 nano ampere, right? Not nano, pico ampere. Then what is the value of collector current? That is the question. The reverse saturation current is given. What is the value of collector current? Is there any one of you having the idea to solve this question? Only given it is base to emitter voltage. Nothing else is given in this question. Beyond this, how do I calculate the value of collector current? I am giving you 2 minutes. Let's see how far you people understand this subject. Try to figure out the answer. I had given basic diode property. Sufficient data is given from my end already. இந்த மாதிரி கொஸ்டின் வந்தா எப்படி சால்வ் பண்ணணும் அப்படிங்கிறதுக்கான க்ளூ ஆல்ரெடி I have given it to you. How many of you are trying? Chalo. See, let me try to solve this question first, because might be you are not getting the idea. It's okay, you are getting the idea also. I'm very happy. The first conclusion what we can do is, anyway transistor is in active region. As usual, you can by default, if there will be no any information about the transistor, you can assume that the transistor is in active region. And the second thing is, when the transistor is in active region, how will you write down the expression for emitter current? Sir, emitter current IE can be written as approximately, not approximately, exactly 1 plus beta times of base current IB. And collector current IC can be written as beta times of IB. Undoubtedly, this is correct, sir. But what happened is, they haven't given any data. Beta value is not given. If beta is not given, then how will you calculate? In the circuit, VCC is not given, base voltage is not given, resistor is not given, base current is not given. If there will be no any data about when there will be no possibility to bring the relation between collector current and base current directly, under all these cases, by default, what I told, assume that the beta is very, very large. When beta is very, very large, approximately the value of base current is equal to 0 ampere. See, when beta is very, very large, then approximately emitter current is assumed to be, it will be equal to 1 plus beta will become what? Beta only. Similarly, collector current IC is already equal to beta times of IB only. சார் நீங்கள் தான் எமிட்டர் பேஸ் கரண்ட் ஜீரோன்னு சொல்லிட்டீங்களேன்னு சொல்லிட்டு நீங்கள் என்ன பண்ணக்கூடாது, இங்கே பேஸ் கரண்ட் ஜீரோ போட்டு எமிட்டர் கரண்ட் ஜீரோ, கலெக்டர் எல்லாமே ஜீரோ சார், இந்த சர்க்கியூட்டே இன்ஆக்டிவ் அப்படின்னு சொல்லிட்டு போயிடாதீங்க. ராங். நான் என்ன சொன்னேன், இட் இஸ் அசியூம்டு டு பி ஜீரோன்னு தான் சொன்னேன். அப்படின்னா மீனிங் என்னன்னா, யூ கேன் ஈக்குவேட் திஸ் டூ, போத் ஆர் சேம் ஒன்லி அப்படின்னு நான் சொல்ல வந்தேன். அவ்வளோதான். யூ ஷுட் நாட் டூ லைக் தட், டோன்ட் ஃபர்கெட். Collector current and emitter current will become equal. That is the conclusion. Okay, sir. Always remember, when you are assuming the transistor is in active region, we all know inside the transistor we have two diodes. One is called emitter junction diode, another one is called collector junction diode. When transistor is in active region, the collector junction diode is in reverse bias. Reverse bias means it will be open circuited. There is no point of talking about this. You can leave it. Your target is only collector, emitter junction. In emitter junction, we will be having our diode in forward bias. And where it will be connected? If you take the transistor, the emitter junction lies between base to emitter. You know how to identify it. This is the way I used to express it. So between base to emitter, it is existing. So anode voltage is nothing but base voltage, cathode voltage is nothing but emitter voltage. Between this only diode is connected. Do you remember? Now I told you what is the generalized expression to write down the diode current. ID equal to reverse saturation current into e power anode to cathode voltage upon eta times of Vt minus 1 ampere. This is the generalized formula. Now in case of transistor, here we will be dealing with the emitter current. This emitter current will be equal to same reverse saturation current into e power. Anode voltage means base voltage, cathode means emitter, just now we saw. So that is called base to emitter voltage upon eta times of Vt minus 1. You can also proceed further. I told you the value of beta is always fixed. It is default 1. Until if it is given in the question, you can take. If it is said, it is given that the value of theta equal to 2, then what can I consider? Take that value. If it is not given, so this ideality factor is always fixed as 1. Then what about the value of Vt? That is thermal voltage, room temperature. You can consider that value is, if it is not given, then take 26 millivolt approximately. It is fixed only. You can take this directly. Now how will you identify the value of base to emitter? You don't need to identify, it is already given. How much? Base to emitter voltage is 0.7 voltage. So from this we can conclude that the value of emitter current, anyway approximately it is equal to collector current. Question is collector current is dash equal to reverse saturation current. How much they have given? Reverse saturation current is 10 power minus 13 ampere. So substitute it 10 power minus 13 in bracket e power 0.7 upon ideality factor is 1 into 26 milli. Milli means 10 power minus 3 minus 1. Proceed further. If you pass this 10 power minus 3 to the numerator, 0.7 into 10 power plus 3, it will become 700 by 26. So 700 upon 26 will be 26 points. So let me write 10 power minus 13 here. E power we will be getting 26.92 minus 1. So if you raise it to the e power, it will be giving you 10 power minus 13. See, this value is very large. It is this e power 26 is very, very large. I am writing it here. See there, 4.926 into 10 power 11 minus 1. So you can also subtract it with the minus 1, but it will not give huge difference. You will be getting almost the same value only. 10 power minus 13 into 4.926 only again I am getting, because that is very, very large, 10 power 11. So approximately you can ignore this 1 into 10 power 11. 10 power minus 13, 10 power 11 will be 10 power minus 2. So 4.926 into 10 power minus 2. Yes or no? Yes, sir. From this I can say it can be further written as 49.26 milliampere. So this is the value of emitter current, or you can also approximately call it as collector current. So the value of collector current equal to 49.26 milliampere. I hope you all understood this one, right? So do you remember this relation? This is very first class I have divided. நம்ம BJT start பண்ணும்போது I have introduced diode first, and I have written the generalized expression for the diode current. Then only we were started the lecture. So if you remember that, it will not be a big deal. You can easily solve this question. Alright. So let me bring the next question. So the next question is, hereafter you'll be able to solve all questions in DC analysis because I have given sufficient thing. இப்போ பாருங்க எவ்வளோ ஈஸியா இருக்கு BJT-ன்ட்டு. தியரிட்டிக்கலா படிக்கும்போது I know there are so many things to study. We have to types நிறைய கொண்டு வருவாங்க, கிளாசிஃபிகேஷன். பட் எதை பண்ணாலும் தியரியிலுமே வந்து எல்லாத்தையும் ப்ரூவ் பண்றதுக்கு only one thing they have applied. What is that? KCL, KVL அவ்வளவுதான். சம்டைம்ஸ் தெவனைஸ் பண்ணியிருப்பாங்க. அதுவும் உங்களுக்கு தெரியும் சர்க்கியூட் எப்போ வந்து தெவனைஸ் பண்ணணும் அப்படிங்கிறது, ரைட்? ப்ராக்டிக்கலாக நம்ம கொண்டு வந்த எதெல்லாம் டிரான்சிஸ்டரில் டிசைன் பண்ணி வச்சிருக்காங்களோ அது எல்லாத்தையும் உங்ககிட்ட காட்டியிருப்பாங்க. தட்ஸ் ஆல். There is no big thing. 49 microfarad this resistor they have given. Circuit is not properly given. I don't know whether it is ground or not. So this is 10 microfarad. This is 430 kilo ohm. This is 2 kilo ohm. Supply voltage is given, and they are measuring the voltage across this V0. This capacitor value is not given. See the circuit shown in the figure. Yes, data is given. Beta equal to 50 voltage. Base to emitter VBE is as usual given as 0.7 voltage. Now the question is, identify the value of base current IB and collector voltage BC. So I hope you will be able to solve this question. There is nothing to solve first of all. One thing I will confirm, just to give me a minute. I don't know whether so this is 1 kilo ohm. So just to do one thing, whether it is connected with some other supply or not, I'm not sure about it. So just to connect it with the ground. You can solve this, okay? Solve this question and identify the value of collector current and collector to emitter voltage. Okay, sir. This is one. Next, I'll be bringing one more question. Don't expect the answer from anyone. If you want to be a genius, then your brain has to work. It's a little different question, but you have to try. ஏன்னா இவ்வளோ நடத்திருக்கோம்ல, உங்களுக்கு இது கூட புரியலன்னா அப்புறம் எப்படி? You can try. This is given 10 voltage. The question is, they told that the value of base to emitter voltage is 0.7. Beta is very large. You know what to do with this. Question is, identify the region of operation. அப்படின்னா என்ன? டிரான்சிஸ்டர் கட் ஆஃப்ல இருக்கா, இல்ல ரிவர்ஸ் ஆக்டிவ் ரீஜன்ல இருக்கா, இல்ல ஆக்டிவ் ரீஜன்ல இருக்கா, இல்ல சேச்சுரேஷன் ரீஜன்ல இருக்கான்னு கேக்குறாங்க. ட்ரை பண்ணுங்க. ஃபர்ஸ்ட் என்ன டிரான்சிஸ்டர்னு பாருங்க. நீங்க ஓட்டினே படப்படன்னு கொஸ்டினை பார்த்தோன்னே சார் கொஸ்டின் கேட்டாங்க சார் இதெல்லாம் நீங்க ஜுஜிபி சார்னு சொல்லிட்டு பிஎன்பி என்பிஎன் டிரான்சிஸ்டர் வச்சு ஃபுல்லா முடிச்சு ஆன்சரை போட்டு வந்துட வேண்டியது. வெளியில வந்துட்டு ஐயோ சார் அது என்பிஎன் இல்லை சார் பிஎன்பின்னு புலம்ப வேண்டியது. ஸோ ஃபர்ஸ்ட் ஃபோக்கஸ் தி டிரான்சிஸ்டர். ட்ரைட். நான் ஏற்கனவே என்பிஎன்னுக்கும் பிஎன்பிக்கும் என்ன டிஃபரன்ஸ்னு சொல்லியிருக்கேன். ஸோ யூ கேன் ட்ரை வித் தட். தட்ஸ் நாட் அ பிக் டீல் ஃபார் யூ. ஓகே, ஸ்பெண்ட் சம்